In this video, we'll be using AI development tools to create this app. It's a command line tool that lets you select a target shell environment, Windows Command Prompt, PowerShell, or Linux Bash. You can ask for the exact command to accomplish some task in that shell. For example, how do I list the files in a given directory in reverse date order? The LLM will give you the exact command for that shell environment, and then the app will optionally allow you to just copy that command into your buffer so you can go and paste and run it. If you're familiar with GitHub Copilot, this is similar to its command line utility. The app will be cool and useful, and we'll certainly be doing coding in this video, but we'll do a lot more. I've broken this video down into chapters as usual, and you're certainly free to skip ahead to the sections that you find most interesting. However, I highly recommend that you watch this video in order. While we will build a working app, my intention here has more to do with getting you thinking about how you can leverage AI throughout your project lifecycle to not only deliver your projects way faster, but also just to offload a bunch of the tedious, boring work that you don't like doing. In the first part, we'll be using ChatGPT to generate our requirements, our design solution, our project plan, and our user stories. And we'll get all of those into some nicely formatted documents that we can just download and place on our web server. Now that first section is only about 5 minutes, and I think you'll find it well worth your time. After that section, we'll get right into our IDE and start using the Aider AI coding assistant to build out our app. The really cool part is that instead of us coming up with all sorts of complex prompts to feed Aider to generate our code, we're going to have Aider directly fetch those web pages that ChatGPT generated for us, and it will use those to easily create the code for our app. Let's get going. We'll be using ChatGPT for the first few steps before jumping over to our IDE for the real fun, the coding. These steps are necessary. You'll see why as we go. Here's the general description of a project we have in mind. We reviewed this earlier. I'm asking ChatGPT to use it to craft a better problem statement. We do this for two reasons. First and foremost, to provide needed context for ChatGPT and later our other AI tools. And two, to get some nicely formatted project documentation out of this at the end. So using our basic project description, ChatGPT generates a better crafted and nicely formatted problem statement for us. As you can see, this problem statement is much easier to understand and is more complete than our original informal description, and this will remain in ChatGPT's memory to guide it in helping us with the next tasks. And our next task is generating a set of project requirements based on the problem statement. Here we're asking ChatGPT to use the problem statement it just generated to create a document that lays out the requirements for our project. We also give some constraints such as, this is an MVP, so keep it simple. And now we have a nicely formatted set of requirements. ChatGPT has covered the functional requirements we provided and also offered some non-functional requirements such as performance and usability. I looked these over and they seem very reasonable to me. But I just thought of another feature I'd like to add to the app. This is an app that runs in the user's terminal. To help the user out, and just to make it a bit cooler, the output should be colorized with different aspects of the output showing in different colors. Let's make that update to our requirements. And here's our update. Just thought of another feature I'd forgotten. We want users to be able to make multiple requests of our app. So we'll have ChatGPT update our requirements to make sure the app loops processing user requests until the user opts to exit the app. And we can see that ChatGPT updates our requirements for looping. Now we often have a chosen tech stack in mind. Maybe it's what our team knows. Maybe we have another reason to prefer a certain set of technologies. For our purposes, I've created a very simple short list of technologies we'll prefer for this project. Python, the Claude 3.5 Sonnet LLM, and Anthropic's API library. And I put this info into this text document. Now I'm going to drag this document into our ChatGPT session. Now ChatGPT is aware of our core technology preferences. We'll ask it to use the problem statement and requirements which it has in its memory already, along with our target tech stack to propose a technical solution to our requirements. The proposed solution document provides an overview of our tech stack and what the tool will do. Then it shows the main proposed software components and their responsibilities. Then it walks through the general application usage and flow. And finally, it wraps up by summarizing the benefits of the proposed solution. This is an MVP to be completed over a 4-week period, so we can probably make do with a very simple project plan. ChatGPT already knows what we're trying to accomplish, as well as our high-level technical approach. We'll give it a bit more info on our team and let it know we work in 1-week sprints. Let's get ChatGPT to propose a project plan for us. ChatGPT laid out a tentative project plan based on our requirements, technical approach, and the guidance we gave it. It's broken down tasks by team role and a timeline for the 4-week period. And it honored our request to have us start coding by day 3. Now we and ChatGPT have everything we need to start creating user stories. We're using Jira, so we'll have ChatGPT start generating Jira tickets. Events happen and plans change, so there's no need to plan in detail past the first sprint. We can always come back and ask for new user stories later. Here, we're asking ChatGPT to use all the knowledge of our project it has in memory to generate all the Jira tickets it thinks we should attack in the initial sprint. We see it generated a set of user stories for Sprint 1. It formatted them nicely for us and included titles, descriptions, acceptance criteria, a set of tasks, and even assigned a team member role for each ticket. We have tickets for the developer, for the product manager, and for the tester. It's great that we have all this information nicely formatted in ChatGPT, but we need to get this documentation into a knowledge base of some sort. We'll start getting all of these docs into web pages, starting with our problem statement. We asked ChatGPT to put our problem statement into a downloadable web page for us. ChatGPT gives us a link. We click to download our problem statement web page, and there it is. Now we'll place this on our web server later to make it available. Next, we'll do the same for our requirements and project plan documentation. We'll end up with downloadable web pages that capture those as well. And here's our requirements web page. And now to generate the web page for our project plan. And here's our project plan. Last step before we use all this great stuff to start building our app. Let's get the Jira tickets ChatGPT created for us into a web page. For now, I'll just ask that the tickets assigned to the developer role be included in that document. And this is the result. A formatted web page with all the Sprint 1 Jira tickets for the developer role. Just a note, I'll be placing all the web pages we downloaded from ChatGPT onto my local dev machine and hosting them using a very simple Python web server. I start with this command. Okay, we're done with ChatGPT for the rest of this video. From here out, we'll be in our IDE actually building and testing our app. I've launched VS Code with an empty project, and I'm going to start the Aider AI coding assistant using the Claude 3.5 Sonnet model. It asks if we want to initialize the project for Git, and we say yes. Now, the first thing we're going to do is we're going to let it know what we're going to provide to it to help it build our project. What we're going to do is we're going to provide it the web pages for the problem statement, the requirements, the solution, and the Jira tickets. We want to just let it know that and say, don't do anything, just store this knowledge in your memory. It says 10.4, we're good to go, gotcha. Next steps. So what we'll do next is we're going to use Aider's /web command and provide the URL to our problem statement hosted on our local Python web server. So now Aider is going to download the contents of that page and store the contents in its working memory. And it explains and summarizes that to us to let us know that it downloaded it and it understands. Next, we're going to provide Aider with the URL for our requirements web page. So it's also going to consume that page. It's going to add it to its working memory. It confirms that it's now stored both the problem statement and our requirements in memory and summarizes our requirements very nicely for us. Now we'll provide Aider with the web page for our design solution. Aider's going to download that as well, add it to its context, and then it's going to come back and confirm, now I have your problem statement, your requirements, and your design solution in my working memory and ready to go. The last project document we'll provide to Aider is the one that contains all our developer user stories for the first sprint. Once it's downloaded this, Aider has a complete picture of our project, including our requirements, our technical approach, and the initial set of functionality we want to build. This will save us from needing to explain all this to Aider, so we can just get going with building the app. One thing that's often helpful in guiding coding assistants is up-to-date documentation on the technologies you're using. This is particularly true if you're using APIs and frameworks that are recent or get major updates frequently. One API we're using is Anthropic's API for Claude LLM access. Here's the web page for that API that walks through various usage scenarios, providing both code snippets and explanations. We'll have Aider add this to its context as well. I let Aider know that I'm going to provide it a web page with some API information to add to its memory. Then I use the /web command to have Aider download that content. Now Ada has up-to-date information on using the Anthropic API. The Claude 3.5 sign-up model is fairly new at this time, so to make sure Ada has what it needs to target the Claude 3.5 model, I'm going to have it also add this web page I found that contains a short code snippet that uses that API to access Claude 3.5. We tell Ada about this new web page we're going to have it add to its context. Then we add that page to Ada. Now Ada has the knowledge it should need to start building our app. We don't need to explain the details of what Ada should do first. It knows our requirements, our tech stack, and our user stories. So we'll just reference our first user story and tell Ada to execute it. As a reminder, this is our first user story, which only involves bootstrapping our project and installing our dependencies. Notice here that I instruct Ada not to do anything beyond what's stated in that user story. Ada analyzes that user story and begins generating a solution for us. It explains the solution to us, including the artifacts it plans to create. Ada then gives us instructions for the exact commands to run to install our dependencies. Then it asks for permission to create the new files that contain the code it generated. We answer yes, and Ada creates those artifacts and commits them to Git. Let's take a quick peek at the files Ada's created so far. We have a very simple main Python script with minimal functionality. We also have a .getignore file to instruct Git on the project artifacts it should ignore, and a requirements.txt file that contains the libraries and versions our app will need. Ada gave us the commands we need to run to install our dependencies. Let's go ahead and run those now. First, we create a new Python virtual environment and then activate it. Then we run the pip install command on our requirements.txt file to get our dependencies installed. Finally, to confirm all is well, we'll run the main.py script. And it works as expected at this point. Now I happen to notice that Ada missed a library dependency that was specified in our user story. It's not in our requirements.txt file. The story stated we needed the paperclip library. Let's try getting Ada to add this. We tell it to review the story again for any missed dependencies. Ada did pick up on one dependency we'll eventually need, the click library, but it still missed paperclip. Let's give it another nudge. We'll be more specific this time. All right, Ada added our paperclip library now to the dependencies list. To get our two new libraries installed, we'll need to re-execute the pip install command for the requirements.txt file. So now we're good to go. Let's move on to our second user story. Our JIRA ticket states the user should be prompted for the target shell environment for which they'll request command assistance. The options should be Windows Command Prompt, PowerShell, and Bash. We'll tell Ada to go ahead and implement this user story. Notice that we're only providing the ID of the JIRA ticket to Ada, and we're also instructing it not to generate anything beyond that ticket right now. Ada generates the code changes necessary to satisfy the ticket, and then at the end it summarizes the changes it's made. And looking at the main.py file, we can see that it's using the Python click library now to present three choices to the user: Command, PowerShell, and Bash. We'll go back to the terminal and run our main.py file again to see the changes. We can see now we're being prompted for Command, PowerShell, or Bash script, and for a query. So we're going to say, hey, I want to find out how to list files. And it's echoing our query just as our ticket says it should. So technically we satisfied the ticket. However, I don't know about you, but I'd rather not have to type in Bash, Command, and PowerShell. I'd like to have a select list presented to me of my options and enter a number. So let's go ahead and ask Ada to fix that for us, make it a little bit more user-friendly. And in reviewing the code changes Ada just made, it does look like we should now be presented with a numbered list of options for each of the shells to choose from. To test that the changes we just made work, we'll go and run the main.py file again. And when we run that script, we'll see that we're now presented with a numbered list of options for Command, PowerShell, and Bash. We'll select option 3 for Bash. It's echoed back to us, you selected Bash. And now we'll just make sure that the rest of the functionality hasn't broken. We'll say we want to list files, and our queries echoed back to us. Now our app isn't yet sending our queries to the Claude LLM. As you can see in this story, CLI 6 adds integration with the LLM. So let's go ahead and have Ada implement this user story next. We go back to Ada, and just like with our previous JIRA tickets, we'll just give the ticket ID to Ada and ask it to add only the functionality for that ticket. So Aider now generates the code for that ticket and then summarizes the changes for us. And we can see in the code some of the changes it implemented for integration with the Anthropic API and the Claude 3.5 model. Okay, let's go test out our integration with Claude. We'll go back over to the terminal. We'll run our main.py script. Now we select our shell, bash in this case. We're going to enter a query, list the files in the current directory in reverse date order, and oops, we've got our first error. Looks like Aider made a mistake with the Anthropic API. So to fix that, we're going to copy that error, go back over to Aider. We're going to give Aider that error and ask it to try to correct it. Now Aider makes some code updates. So let's go back again and test to see if it fixed the bug. We rerun the main.py script again and give it the same queries we did before. Oops, another error. This time I'm guessing it's on us because it's complaining it can't find an Anthropic API key. Let's go ahead and see if we can get some more help from Aider to fix this one. We'll copy that error. We'll go back over to Aider terminal and we'll paste that error in and we'll ask for some help from Aider. After it does some analysis, it comes back and says, hey, there's a .env file that you need to set an Anthropic API key environment variable in. I'm going to go ahead and update my .env with my API key off screen. Now we'll retest our app. We'll provide the same user inputs as we did last time. And this time, we get a bash command that satisfies our query. This means that our app is now integrated with the Claude 3.5 model. Now let's copy the command Claude gave us and exit the app. To see whether the LLM gave us the right command for our query, we paste the command in our terminal. And that output looks correct. We'll implement one last user story together. We're done with the developer stories for Sprint 1, so we'll choose the first developer story from Sprint 2. This story adds some color to our so far boring app output. Now our Sprint 2 stories are on a different web page than our Sprint 1 stories were. We haven't yet had Aider load the Sprint 2 stories into our context. So first order of business is to have Aider load that web page into its context. We're going to start by informing Aider what we're about to do. We're going to give you the Jira tickets for Sprint 2. Then we'll use Aider's /web command with the URL for the web page to have Aider add the Sprint 2 tickets to its context. And just as with the other Jira tickets, we ask Aider to implement just that Jira ticket without any other functionality, and Aider makes the changes for us. Aider summarizes the code changes it made, and it also tells us which colors it's going to use for different parts of the output. Now let's go over and test our application again. And now we can see that our output's colorized with different parts of the output in different colors depending on the role of that particular part of the output. Let's have Aider generate a unit test for the select shell function. At the end, it gives us a summary of the unit tests it created and some enhancements it's making to the main code to make the code more testable. We'll go run these unit tests. Here's the unit test script that Aider generated. We can run the tests and see they're passing. Of course, we've only executed a portion of the project's use cases in this video. We stopped development after adding color to the app's output. But the developer also has a Sprint 2 story that allows the user to request the app to copy the generated command to the buffer. And in Sprint 3, the developer has other stories such as optimization, and later for enhanced error handling, etc., etc. And the tester and project manager also have assigned work. And even though we won't be directly addressing the use cases we've documented throughout the rest of this video, stick around because there's several other cool things I want to share with you. Also in the description, I'm going to provide the link for the GitHub repo where you can clone this project if you want to run it yourself. It's a more complete project than the one that we've developed so far. For instance, that version of the project which you can clone has the copy command to clipboard functionality. So here we can see we've run our application and it's asking us if we would like to copy it to the clipboard. We'll say yes. And I'll simply paste that into my terminal and you can see it's the same command that the LLM generated here. I'll run that command and we're good. So now that represents the full functionality for our application. Again, you can download that from the GitHub repo. Now we can use AI to analyze our existing code for issues and improvements as well. To demonstrate this, I've added a function to our main.py file that's never called. I'll ask Aider to review our code base to locate dead code. Now we can see Aider finds that dead code. So let's have Aider go ahead and remove that for us. When Aider finishes, we can see that that function no longer exists in our code. Our project needs a README file. Aider can do a great job of creating one for us. We ask Aider to create one that describes what the app does, the technologies it uses, and how to run and use the app. Aider uses all the knowledge it has of our app to create our README. And we can see that it did an outstanding job. It's covered all the bases we requested. App description, technologies used, how it works, how to set up and run the app, and how to run our unit tests. But we're not quite done yet. One last step. We'll ask Aider to generate a sequence diagram that shows the main flow between our app's components in plant UML format. We tell Aider to place the plant UML in a file named sequence.puml. Aider produces the plant UML, and we can now see a file named sequence.puml in our project folder. We can install a VS Code extension named PlantUML that will let us turn this text file into an image. With this extension installed, we can open the sequence.puml file, then right-click and select the Preview Current Diagram option to view it as an image. We then select the Copy button to save this image as a PNG file to our workspace. And just like that, we have a really useful sequence diagram contained right within our code base that we can embed into our external architecture docs or into our README. We could also generate other diagrams such as component or class using the same procedure. Now, I hope this video inspired you to explore more ways to use AI to get more done and have more fun. There are other videos on this channel that show how to use AI to develop apps. If you found the topics in this video interesting, I think you'll find those videos enjoyable as well. If you'd like to see more videos on this topic or similar topics, please do let me know in the comments below. And if you enjoyed this video, please like and subscribe. I'm Tim Kitchens, Coding the Future with you, and I look forward to seeing you in future videos.